So on this video, we're going to be explaining how to work out these problems, the majority of these problems on worksheet 4.4 WSP, which is dealing with writing equations, given that your equation is parallel or perpendicular to the equation that they give you. So everybody right here on side one, this is the parallel side. So you might as well write that parallel side, right? Now, what does that mean? On the instructions, it says that your line passes through the given point. So they give you a point, and then it says, and is parallel to the given equation. So they give you an equation, and they're telling you that your equation that you need to write is going to be parallel to that equation. And what we need to know is that the definition of parallel means same slope, same m value. Okay, so parallel means same m value. So in reality, they give you a point, and the point is obviously x1, y1, which is negative 2, 5 in this case. And they give you an equation, and they tell you that your line is going to be parallel to this line right here. And what does it mean to be parallel? That it's going in the same direction, it won't intersect, which means it has the same slope. So this slope right here, if you think about y equals mx plus b, the slope is negative 4. And if we know that our line is parallel to this line, that means that we have the same slope. So we're going to have an m right here. And we know that our equation is going to have the same exact m value of negative 4. And that's a very important piece of information when you want to write an equation. Okay. Now, I've been explaining just one way of doing it most of the time, but on other videos I explain two different ways of doing it. One is strictly with slope-intercept form, right? Since they ask in the instructions, write it in slope-intercept form. Right here, slope-intercept form. We need to know that slope-intercept form is y equals mx plus b. Okay? So if we wanted to write it in y equals mx plus b, we could just only use that form, even though it's kind of complicated, I would say. So to use y equals mx plus b, you need both an m and a b. So obviously, we have an m, we don't have a b. But what do we have besides a b? We have a point. So, I mean, my thought would be, since I have a point and I have a slope, write it in point-slope form. Okay, that's what I would do. But let's say you didn't like point-slope form. Let's say you only wanted to stick with slope-intercept form. Then you could actually take y equals mx plus b and plug in what they give you. They give you an x value. That could go right here where the x is at. So you could plug in the negative 2 where the x is at. We already know our m value. It was indirectly given to us by them telling us that our line is parallel to this line. So our m value is negative 4. We're going to put a negative 4 right here. And we have an equal sign. And we have a y value. The y value is 5, and we can plug in that 5 right there. Let me draw an arrow from the 5 right there to the y, so we have a 5 right there. And of course, we don't have a b value, so I'm going to bring down the plus b. Plus b. So, and we haven't practiced this way in the other class periods, so we're trying this out. If you like it, you could use this. If not, you could always go back with what I like, which is point-slope form. Again, I would say, oh, I have a point, I have a slope, I'm going to go for point-slope form. But if you wanted to, you could rewrite y equals mx plus b, plug in this as your y, plug in this as your x, plug in the m value of negative 4 right there where the m's at, and then you'll have an equation that has a bunch of numbers and math operations with just a plus b at the very end. And now you could actually solve this equation for that b value. So you could say, okay, negative 4 times negative 2, that's positive 8. So what we really have is equal sign 8 plus b with the 5 on this side. And then you could solve this equation by subtracting 8 and subtracting 8, giving you negative 3 equals b. So my b value that I needed is actually negative 3. So now I do know my b, and I already knew my m because they told us it was parallel. So now that I know that my m and my b, I could actually write my equation in y equals mx plus b form, which is going to be y equals negative 4x plus negative 3, or just minus 3. There's my equation. That's what I wanted. Does that make sense? Okay. I don't know. You might like that method. If you do, and you think it's a lot easier than point-slope form, go for it. Now, normally what I would do is, I have a point, and they indirectly gave me a slope because they told me that my line's parallel to this one, which means that my slope is -4. If I have a point and I have a slope, I would choose to write it in point slope form, which is y minus y1 equals m parenthesis x minus x1. So you could leave it with blank spots, y minus blank spot equals blank spot parenthesis x minus blank spot, and plug in your y1 value of 5 right there. That's an ugly. Oh, give me 1 second. There you go. And then plug in your x1 value of -2 over here into the x1 spot. And of course, plug in your m value of -4 right here where the m is at. And now that's in point slope form. However, they did want it in slope intercept form. That's what the instructions say. So we need to get y by itself, and we want to get rid of the parentheses. Get rid of the parentheses first. And before even distributing, you have to change the minus to plus. Then you would distribute that -4. -4 times x is a -4x. -4 times +2 is a -8. Bring down the equal sign. Bring down the y, the minus, and the 5. You have a one-step equation now to get the y by itself. All you'd have to do is get rid of the -5 by adding 5 and adding 5. And you'd have your final slope-intercept form equation, y equals, because that eliminated, the -4x comes down, and -8 plus 5 is -3. So as you could see, it's the same, y equals -4x minus 3. Same slope-intercept form equation done 2 different ways. It just depends what you feel more comfortable with. Do you feel more comfortable with just using y equals mx plus b? Right? If you wanted to just use y equals mx plus b, they give you an x and a y. You could plug in your x where the x is at. You could plug in your y where your y is at. They indirectly give you the m because it's parallel, so you plug in the m where the m is at. That way you have a bunch of numbers and math operations and a plus b at the very end, which means you could solve the equation for b. And you'd find out what b is, and once you know the m, and once you find out that b, then you could write it in y equals mx plus b form. Or you could recognize that they give you a point and indirectly a slope. So you could go with point slope form, plug it in, and then just change the way it looks to get it in slope intercept form. Let's jump to number, let's go to 6. That one's interesting. So again, we need to remember the instructions. They give you a point. Your line, the equation you want to write, your line's going to pass through the location 3, 1. And in addition to that, it's going to be parallel to this line. And we don't even see this line. And actually, I don't even know the slope of this line. Why? Because it's in standard form. So the very first thing I need to do to be able to find my slope that's going to be parallel to this one is to make sure that I could see this slope, right? So how am I going to change this to a different form so I could see the slope? Anybody? Yeah, you're going to subtract 2x. You want to get y by itself, so it'll be in y equals mx plus b form. So if you subtract 2x, you're going to end up with y equals -2x plus 5. Now, this is in y equals mx plus b form. It's really easy to graph now if I were to graph it, but the only thing I really care about this equation, the whole purpose of getting y by itself, is for me to identify the m value of this equation. Why? Because the instructions say that mine is parallel to this one, and if my line is parallel to this one, what does it mean? That I have the same what? Slope, and the slope here is what? -2. So our slope is going to be -2 as well. See, all the work I did right here with this equation, all that work is just to find that -2. I don't even care about this equation anymore. If I wanted to, I could just draw a line through it and never look at it again, because I already got this important bit of information that my slope is -2. And that's only because they told me my line's parallel to this one. If they would have said perpendicular, then it would be the opposite reciprocal of what I see here. Anyway, what do I have now? I have a point and a slope. So I normally would go for point slope form, which is y minus y1 equals m parenthesis x minus x1. And whenever I use this, I always go with blank spots. Y minus y1 equals m parenthesis x minus x1. And then I plug in my x1 from that point and my y1 from that point. So my y1 is 1, and my x1 is 3, and my m, because it's parallel to the given equation that we switched to slope-intercept form to find out that slope, is the same slope, -2. And now at this point, because the instructions say write it in slope-intercept form, y equals mx plus b, you're going to have to get rid of the parentheses by distributing that number, and then you'd have to get y by itself at the very end. So let's distribute first. We're going to go -2 times x, that's -2x. -2 times -3, that's +6. Bring down the equal sign, bring down y minus 1. We almost have y by itself. All we have to do is get rid of that -1, bless you, by adding 1. And when you do to one side, do to the other, add 1 there. You're going to have y equals, the slope is -2 in front of the x, and then +7. I guess I should have done the b value in red. There you go. So this is my slope-intercept form equation. That is the answer to this problem. Was that difficult? For me, it's not. Maybe for you, you're like, I don't like point-slope form. Okay, so an alternative method is to go for slope-intercept, because the instructions say write it in slope-intercept. So maybe you just want to stick completely to slope-intercept, y equals mx plus b. So for slope-intercept, you need an m, which for sure we have. The m is -2, but we also need a b value, so we could plug in that b value right here. Okay, so we don't know the b value. Now, we already know the equation. We're done. But I'm just going back and explaining it a second alternative way of just with y equals mx plus b. Okay, so you get to choose which one you feel is better. If you like this, it's great. You don't even have to do this, right? But then again, you want to do both. It's more exercise for you. You'll understand both forms better. So what do I have? I have a point and I have a slope. So my point is technically an x value that could get plugged in right here, and my point also has a y value that could get plugged in over here, and the m could get plugged in right there, which means I'd have a bunch of numbers and math operations with a single variable b, which means I could solve for b. I could get b by itself. So let's do exactly that. I'm going to take the 1 on the y and put it right there where the y is at. So there's a 1 right there. 1 equals, I'm going to take the m value of -2 and put it right there where the m's at, -2. Now notice that there's no sign between the m and the x, so I'm going to put a dot right there, which means I'm going to multiply. And I'm going to multiply by what? By the x value. And what is my x value? My x value is 3. So I'm going to take this x value of 3 and put it right there where the x is at. So there's a 3 right there. And I still have the plus, and I still have the b. I don't know b. That's what I want. I want to solve for b. So solving this, I'd have to go -2 times 3. That'll be a -6. Bring down the plus b, bring down the equal sign, bring down the 1. You want to get rid of that -6. You're going to add 6, do the opposite. When you do to one side, do to the other, add 6. You're going to end up with 7 equals b, which means that b equals 7. Now that you know the b value of 7, you have the m and the b. Now you could write it in y equals mx plus b. Y equals -2x plus 7. Y equals -2x plus 7, which obviously is the same thing that we got over here. I don't know about you guys. For me, I like point. I see the point and I see the slope. I'm like point-slope form. I have a point, I have a slope, I'm going to go for point-slope form. And then after that, it's just a question of distributed property and moving things around to make it in y equals mx plus b form. But if you actually like to only work with y equals mx plus b form, you could just do this, write it down, plug in your x right there, your y right there, your m right there, solve the equation for b, then you have an m and a b, which means you'll be able to write in y equals mx plus b. All right, so this front side was all on lines that they want you to write that pass through a given point and are parallel to a given equation, which means same slope. The back side of this worksheet, if you flip it over, you have the same instructions, write an equation in slope-intercept form, y equals mx plus b, that passes through the given point and is perpendicular, okay, to the given line. So perpendicular is not same slope. Perpendicular is opposite reciprocal slope. Opposite reciprocal slope. What the heck does that mean? The sign has to be changed and the fraction has to be flipped, okay? Change sign, flip fraction. That's what it means, opposite reciprocal. You change the sign, you flip the fraction, okay? So looking at this worksheet, let's go for the first one, number 13. We know that our line passes through this point, x1, y1. And we know that our line is perpendicular to this equation here. What does perpendicular mean? That our slope is going to be opposite and the fractions are going to be flipped. So our slope, our m value, is what? Has to be an opposite and a reciprocal of negative 1/3. Positive 3, right? I mean, yeah, you could say positive 3 over 1, but the best way of writing that would just be m equals 3, right? Change to a positive, flip the fraction, it'll be 3 over 1, but the best way to write is just m equals 3. Okay, so what do we have here? We have a point and we have a slope. Where point slope form is y minus y1 equals m parentheses x minus x1. And whenever I use this form and whenever you use it, I recommend writing it with blank spots. Y minus y1 equals m parentheses x minus x1. That way I could easily plug in my y1 value right there, which happens to be negative 2. Our m value, which happens to be 3 right there, right? M is 3, put it right there. How do we get this m? By knowing that it's perpendicular to this guy. So you changed it and flipped it, right? Positive 3 is our slope. And our x1 value is also negative 2. So plug in that negative 2 right there. Those minuses change to plus plus. Now, if the instructions would have said write your equation in point slope form, you would be done right there. That would be it. But they say write it in slope intercept form. They want y by itself, and they definitely don't want those parentheses. So go ahead and distribute 3 times x, that's 3x. 3 times 2, that is positive 6. Bring down the equal sign, bring down the y plus 2. We almost have the y by itself. All we have to do is get rid of that 2 by subtracting 2 and subtracting 2, giving us y equals 3x plus 4. And we are done. That's our slope-intercept form equation, where our slope is 3, or 3 over 1, and our y-intercept, our b value, is 4. If I wanted to graph it, it would cross the y-axis at 4, and I would rise 3 and run 1. Now, again, I just want to explain it both ways. If you understood that, you're done. But I'm putting the squiggly line right here to show an alternative way, just sticking with y equals mx plus b. And you could plug in what you know to find out what you don't know. You see, to be able to write an equation in y equals mx plus b, you need the two things, the m and the b. We already know the m. We still need to find the b. If I knew the b, I could just plug in my m right there, my b right there, and I'd be done. But I don't have the b. So what do I have? I have a coordinate, an x value and a y value that I could plug in right there, x right there and y right there, and I could plug in my m right there. Therefore, it'd be an equation with a bunch of math operations and numbers and a single variable b, which means I could solve for b and find that missing b value. So instead of y, what would I write? Negative 2, that's right. Bring down the equal sign. Instead of m, what would I write? 3. And instead of x, what would I write? And notice I'm putting this parenthesis negative 2. Actually, I should have done it in red to stay color coordinated, right? The x value is negative 2. Plug that in right there. But if I didn't put in parentheses, or if I didn't put a dot, I'd probably think that I'm subtracting 3 take away 2, and it's not 3 take away 2, it's m times x, so it's 3 times negative 2. And at the very end, we have the plus b. So let's do the math. We're going to multiply 3 times negative 2, that's negative 6. Bring down the equal sign, bring down the negative 2, bring down the plus b. You want to get rid of that negative 6, do the opposite. Whoops. Actually, let me change the color of it. Negative 6. We're going to do the opposite of negative 6 by adding 6 and adding 6, giving us 4 equals b, which means b equals 4. So now that we know the m and the b, now we can plug it into y equals mx plus b. And there's your slope-intercept form equation, y equals 3x plus 4. Again, I prefer point slope. I prefer, once I have a slope and once I have a point, I jump right to point slope form, plug it in, and then change it. Or if you wanted to. You could just stick with slope-intercept, plug in your x, your y, your m, solve for b, and then take your m and your b and plug them into y equals mx plus b. Jump into 21. All right, so again, we're still on this side, on the perpendicular side, right? The first side was parallel side, this one's perpendicular. Again, the instructions say, write an equation of the line in slope-intercept form that passes through this point and is perpendicular to this one. So if I saw the slope of this guy, my slope is going to be perpendicular to it. So if this slope was positive 2, then my slope would be negative 1/2. If this slope was like negative 5/7, then my slope would be positive 7/5. Are you guys following me? Perpendicular slopes, okay? But the thing is, the problem is, I don't know what the slope is right here. This is in standard form. There's no m in ax plus by equals c. So I need to change the way this looks to be able to see the m value. Okay, so I'm going to change it to y equals mx plus b. I'm going to get y by itself by subtracting 2x. Rewriting it, I have a negative 5y equals, I can't really subtract negative 10 and 2x, so I'm going to just rewrite it, negative 2x minus 10. My final step is to get rid of the multiplication of negative 5 right in front of the y. So I divide everything by negative 5. Everything by negative 5. Giving us a slope-intercept form equation, y equals, and when we say negative 2 divided by negative 5, yeah, 2 divided by 5 you can't do, but a negative divided by a positive, a negative divided by a negative is a positive. So at the very least, I could write it as a positive 2/5 with the x on the side. And the b value at the very end, negative 10 divided by negative 5, that is a positive 2. So there's my slope-intercept form equation, not of my line, but of this line that was given to us, right? This line that was given to us. Now, why did I change it to slope-intercept form? So I could see the m. The m happens to be what? 2/5, which means that my m happens to be what? Negative 5/2. Because remember, perpendicular, and that's what the instructions say, that our line is perpendicular to this line. Perpendicular means opposite reciprocal slope. So if this is positive, the opposite would be negative, and reciprocal means you flip the 2/5 and it becomes 5/2. So a negative 5/2. Negative 5/2 is our slope. Now at this point, I don't ever have to look at this work that I did again, because I already got the information that I wanted. What do I have now? I have the slope of my line, and I also have a point that my line will cross through. So once again, I love to go with the information they give me. They give me a point, they give me a slope. I want to go with point slope form, which is y minus y1 equals m parentheses x minus x1. Whenever I use it, I rewrite it with blank spots. Y minus y1 equals m parentheses x minus x1. I said it, but I didn't write it. Why did I not write it? Because I'm going to actually plug in the y1 value. The y1 value is negative 5. Put that right there. So that's going to be a negative 5. And the m value happens to be negative 5/2. So I'm going to put a negative 5/2 right there. And you guys picked a winner. This is a challenging question. And the x1 is a 4, so I'm going to put a 4 right there. Who knows? Maybe just sticking with y equals mx plus b will be easier on this one. But let's just keep working. Anytime you have a minus minus, you change it to plus plus. Okay? So what we really have is y plus 5 equals negative 5/2 times x minus 4. So I want this in slope-intercept form, which means I'm going to have to distribute the outside number to the inside, right? Right here, it actually is not that bad. Okay, now like if I had a 5/7, then it would be more challenging and I would get rid of the fraction. But because we have this divided by 2, then technically you could actually divide 4 by 2. So it does work out fairly nicely. When I distribute negative 5/2 times x, that would be a negative 5/2 with an x. And when I go negative 5/2 times negative 4, well, a negative times a negative is a positive, and you could make a fraction and multiply the top with the top. 5 times 4 is 20, so you'd have a 20 up on top. And on the bottom, you'd have 2 times 1, which is 2. And the only other detail here is that 20 divided by 2 is 10. So our new equation is a plus 10 right here, a negative 5 halves x right there, an equal sign, right, that keeps coming down, and a y plus 5 on this side. All I need to do is get y by itself. So all you need to do is subtract 5. Subtract 5. You'll have y equals negative 5 over 2x plus b, which happens to be plus 5 because 10 take away 5 is 5. And that is our slope-intercept form equation, y equals mx plus b. Now, the alternative way would have been to just stick with slope-intercept form, which is y equals mx plus b, and plug in the y value of negative 5 right here on the y spot, negative 5 on the y spot, bring down the equal sign. The m value of negative 5 halves right here where the m is at. So the m value of negative 5 halves right there where the m is at. The x value, and remember, we are multiplying m times x, so I'm going to put times, and I'm going to put the x value in parentheses. And the x value happens to be 4, so you could plug in a 4 right there. And then you would have the plus b at the very end, just bring that down, plus b. And at this point, you have an equation that could be solved. All you got to do is a little bit of multiplication right here, 5 halves times 4. And again, you could put the 4 over 1 and multiply the top with the top, bottom with the bottom, or you could cancel first and then multiply, but I'm just going to stick with multiplying first, then reducing. So up on top, you have negative 5 times 4, that's negative 20. And on the bottom, 2 times 1, that's 2. So the equal sign's here, the negative 5's here, the plus b is over here. And if we think about it, negative 20 divided by 2, that's a negative 10. Negative 10 plus b equals negative 5. Get b by itself, so you're going to go add 10 to get rid of that minus 10. On the left side, you're going to have a 5. On the right side, you have the b, which means that b equals 5. So if you know your m and you know your b, now you could write it in y equals mx plus b. So there's your equation, y equals negative 5 halves x plus 5. Same exact equation as over here. That's probably the hardest type of question that there is. And again, this is only long-winded and looks like a lot of work because I did it in 2 different ways. You could only do it this way, or you could choose to only do it this way. It's up to you. I did it both ways, or like I said, if you want more practice, you could do it both ways also. It'll just make you smarter, all right? So I'm going to end this video here. It's already long enough. Let's work on the rest of this worksheet for the rest of the period.